วัสดีค่ะขอต้อนรับคุณผู้ชมทุกท่านนะคะเข้าสู่ค่ะ Academy แหล่งเรียนรู้ช่องทางใหม่เพื่อการอัพสกิลและเสริมสร้างศักยภาพนะคะโดยเรียนรู้จากผู้มีประสบการณ์ตรงในหลากหลายสาขาวิชาค่ะวันนี้นะคะอยู่กับทาง Academy ใน EP ที่116แล้วค่ะซึ่งวันนี้นะคะตรงกับวันพุธที่20ธันวาคมนั่นเองค่ะหัวข้อในวันนี้นะคะเราได้รับเกียรติจากวิทยากรหลากหลายท่านเลยนะคะที่จะมาร่วมเสวนากันค่ะซึ่งวันนี้นะคะหัวข้อดังกล่าวก็อยู่ในเซสชันที่4ของ Thailand Halal SMB 2023 ที่ผ่านมานั่นเองค่ะหัวข้อนะคะได้แก่เรื่องของ Innovation in Food and Ingredient from Nature Body to Advanced Solution นั่นเองค่ะและเราได้รับเกียรตินะคะจากวิทยากรนะคะดรสุเรนีดรอุมมาและดรนาซีมานั่นเองค่ะและอีกหนึ่งท่านนะคะที่เป็น Moderator ร่วมดำเนินรายการกับเราในวันนี้ค่ะดรซีมานั่นเองค่ะเอาเป็นว่าซีน่าขออนุญาตยกช่วงเวลาต่อจากนี้ให้กับ Moderator ของเราได้ดำเนินรายการต่อค่ะขอเชิญค่ะ
Good afternoon, ladies and gentlemen. Assalamu alaikum and swadika. So, I'm Dr. Simab and thank you very much to the organizers of the conference for extending the kind invitation to me to participate in the conference as a moderator. And I believe that this is the time of the day that most of you feeling so maybe lethargic, and all of you have been up since very early morning, and right now maybe just stay a little bit longer with us because this is the last session and last round of presentation. And I'm so glad to make this announcement to you that the next three presenters, they have different topics to discuss today relevant to the halal industry and halal products and how the science can contribute to that. So please stay put a little longer with us, and we have three very good speakers onward that will contribute their research findings and their opinions and discussion regarding the innovations in food and ingredients from nature's bounty to advanced solutions. So without further delay, I would like to extend my invitation to the first speaker. She is Professor Dr. Nazimah Hamid from Department of Food Science and Microbiology, Auckland University of Technology, New Zealand. I would like to introduce a bit about her. Dr. Nazimah is a wonderful cadre of female scientists in the field of food science and microbiology who have accomplished a career of nearly 30 years, demonstrating academic and administrative leadership in food science. She had a significant track record in leading research projects, as well as fostering and inspiring research students to publish in very high quality and impactful journals. She had established a strategic collaborative research with Food Industry Research Institute at international level, and she had over than 200 publications with numerous contributions in literature as book chapters and other journal articles and reports. She is also the fellow of New Zealand Institute of Food Science and Technology, as well as the professional member of the Institute of Food Technology. And today she will be sharing her work about the unlocking the hidden potential of food byproducts that are most relevant to the conversion of the food waste into sustainable, functional food ingredients. That is quite interesting to listen to her today, what she is going to discuss with us. So without further delay, please welcome Dr. Nazimah. The floor is yours. And I would like to announce that we have 15 minutes for each speaker in this round.
So we'll go to the next one. Oh, okay. Assalamu alaikum. I'm Nazimah, and I'm from the Auckland University of Technology. It is the youngest university in New Zealand, so about maybe 15 years. And this is my research group. And you can see we have someone from the Halal Science Center here, Marisa. She spent 11 months with us, so I was very, very happy. Alhamdulillah, we have a student from here. I was very, very happy. And this is actually the day she was about to leave. So this is the function that we had to celebrate her time with us. So I'm going to talk about unlocking the hidden potential of food byproducts. And this is because there's a lot of problems with sustainability, and green is the way to go. So I'm just going to show you this slide. It's just showing you how big the scale is in terms of global food waste. And you can see here China contributes to a lot of waste in this graph that you have here, followed by India, and you can see Australia right at the down there. And where are you getting this food waste? Generally, it's your household waste. Yeah. So you can see out of the 931 million tons, the household waste accounts for 569 million tons, followed by food service. So you get your restaurants and, of course, your retail sector as well. How about New Zealanders? So what is the top 10? A lot of bread away because, yeah, your bread will get moldy when it's sitting on the shelf. Then there's leftovers, potatoes, apples, chicken, bananas, yeah, banana peel. I see some people here already using banana peels, byproducts in some of the formulations. I think that's great. Lettuce, oranges, pumpkins, so even citrus fruits. A lot of pectin can be obtained from the citrus peel. So we can actually use these things that we throw away and make it into something more valuable. All right. So everything is bioeconomy now. So the circular bioeconomy is playing a big role, and it encompasses the production of renewable biological sources. All right, so you can have a variety of products that you can produce for biohealth, bioenergy, agribio, and even bioindustrial. And I can see a lot of the products that you have showcased. It's very related to biohealth. So why is it important? Okay, the valorization of refuse that would actually otherwise end up in your landfill sites. A lot of the industries in New Zealand pay a lot of money to dispose of this waste. You know, you can't just go and dig a ground and put your waste in there. So a lot of nations are now promoting bioeconomy as a sustainable development strategy. And this aligns, yeah, with the United Nations goal of green sustainable development. This is beautiful New Zealand. I've been in New Zealand for 17 years now. I just don't get tired with the sceneries we have there. We have abundance of land, water, and strong primary industries. And you know, we have more sheep than people in New Zealand. Yeah? So we are, again, not heavily reliant on fossil fuels. So 95% of the New Zealand energy comes from renewable sources. So we're quite environmentally conscious. So there are favorable conditions for us to transition to a plant-based economy. I'm going to talk about avocado. And I know that in Thailand, you have avocados here too. And I look forward to trying them, but I guess they're not in season. But we have a lot of avocados there. And what do we do with it? Most of the time, we use it for oil production. And we use it for oil, for culinary uses. And what happens? We get the waste byproduct. Whenever we throw this waste, it is of a concern. to industries. They have to pay to get rid of the seeds, the peels, the wastewater. You can't just, get the wastewater and put it on, into the drains. It's not just good. So we looked at the possibility of valorizing the waste. Yeah, so this is a project converting industrial avocado waste into valuable functional ingredients, and this was carried out by our PhD student, Rahul Permal, with his co-supervisor, Rothman Kam, me, Brent, and Joe. And where did we get this waste? We got this waste from the avocado oil company. So basically, we are getting all our ingredients for free. And they would even post it to us for free. Okay. And we actually obtained funding for this project under Callahan. So I'm just going to talk about the cold-pressed avocado oil, CPAO. Originally, in the 1940s, avocado oil was only extracted for cosmetic purposes. But now, we've seen an increase in its use in culinary. And that started in New Zealand in the 1990s. And that's what started the mechanical extraction via cold pressing at less than 50 degrees Celsius to retain the color and the bioactive components of the oil. So first of all, we went to the factory and we got the student to measure how much of byproducts were being produced. So we have the pomace, and then we have the seeds, the skin, the wastewater. So this was all published. And you can see we get a lot from skin and seeds. Then we have the pomace next. The pomace, generally, you don't have much oil, okay? You've extracted most of the oil, so it's mainly just dietary fiber. And then there's wastewater and residual water. If you look there, the biggest source of waste there is wastewater, and that's one of the projects that we worked on. So the research aims were to convert the byproducts of cold-pressed avocado oil into higher value products and reduce the amount of organic waste that goes into your landfill. Makes sense? So let's look at the pomace. It's low in lipids, digestible, quite high in digestible carbohydrates. We use it as an animal feed. The skin, okay? The skin is really good. Again, a high level of non-digestible carbohydrates, mainly cellulose and hemicellulose. I've got a PhD student now looking at extracting the bioactive components of the skin, okay, and encapsulating it to make a functional food ingredient. But there's also the possibility of using the skin for biodegradable packaging. So basically, how do you make a biodegradable plastic? You'll mix cellulose with zinc chloride solution, okay, and add 0.5% glycerol. And that's what you get, the one that's white there, made with crystalline cellulose. And we've actually tried using the skin to make this plastic, but instead of using cellulose, you can see that we've used dried avocado skin. So there's some potential there. The wastewater. So there's a lot of wastewater generated, and so what do you do with the wastewater? It's the largest byproduct in terms of volume, and so there's a big problem in terms of disposal issues, and that's because it has high lipid content, roughly 6% there. And it's not, we spray dried it and turned it into a powder, and you can see that there's an increase in the antioxidant activity, so there are a lot of good bioactive compounds in there that you can valorize. We've also looked at the vitamin E comparison, And you can see with the different byproducts, wastewater actually, the wastewater powder actually had between 200 to 300 milligram per kilogram of vitamin E. And in your flesh, you're only getting what, about 20 milligrams, and in the oil, only between 70 to 190. So this is good, yeah? This powder that we produced, spray-dried powder, was really good. And this is what we do. We have a slurry, and we add some cell wall carrier materials. It's mainly maltodextrin, and that's the spray dryer. And that's the powder that we get. Yeah, so we know it's got good antioxidant activity. We know it's a good source of vitamin E. So what do? We try incorporating it into a meat product. And we use sausages. It's quite interesting when you compare the avocado wastewater, which is AWW, and you compare it to the chemical preservatives like BHT and BHA. Okay, those two chemical additives are in fact carcinogenic, yeah, if added at high amounts. And we looked at the avocado wastewater powder, and it was working really well, because you can see the T-bars results, which is a measure of rancidity, is not significantly different to the chemical preservatives there. The seed is my favorite. We've actually had a couple of students from France and UK, and they've been working on getting an extruded product. So we've managed to produce an extruded product using avocado seed, because you see, we've got quite a lot of available carbohydrates there, and this can, you know, we have the possibility of making a gluten-free snack product, which is again healthier because the seed has also got a lot of bioactive components in there. So we've got some extruded snack, and we've just done some sensory testing, and it looked like most people actually like the snack that contain up to 40% of the avocado seed powder. So that's good news. Yeah, you get ingredient, you pay nothing for it, and you can sell a healthy product. We had problems with bitterness and brittleness, but that was overcome by the addition of brown rice as well. So we managed to improve the formulation. But again, this extruded snack is high in antioxidants. That's good. We've made sure there are no toxic compounds, so we've checked for amygdalin and persin to make sure that the products are safe to eat. All right, so the next one is looking at fermented seed as functional ingredients. This is carried out by my PhD student, Jimmy. His Chinese name is Jiu Zhao. And we looked at the fact of fermenting the seeds, and it was really exciting when we found that, oh, you get even more bioactive compounds with fermentation. So we use Lactobacillus plantarum, and this actually increased the total polyphenolic content and antioxidant activities compared to kefir and naturally fermented samples. We also looked at the anti-cancer activity, and this seed powder was very good in terms of inhibition of breast cancer cells as well as liver cancer cells. And we found the optimum conditions for antioxidant activity and anti-cancer activities by roasting. It's an amazing thing, and so we recently published this, and we've looked at the different metabolites. We are carrying out some proteomics analysis. We are hoping to get bioactive peptides as well. And what next? This is the last one. And We are looking at apricot kernels now, and that's also very exciting. And did you know that an apricot kernel contains up to 23% protein? Yeah, so it's a very good source of protein there. And so we again subjected that to fermentation, and we are looking at the bioactive peptides in there. Conclusion. All right, so we know that food waste is a significant challenge that contributes to environmental pollution and economic losses. And so why not convert this food waste into valuable bioactive compounds, biofuels, and you know, add it in your food, add it in your cosmetics. It's really a valuable resource. It's not something that you just can, I mean, this is what people do, throw it away. But you know now, a lot of people are in this area, and there's a lot of interest in the conversion and valorization of these valuable byproducts into something that is healthy, okay? Because that's what people are so interested in now. Thank you. That's all.
Thank you very much, Dr. Nazimah, and it was really interesting to listen to her outcomes of the research work. You know that climate change it is said that it is for real and it is affecting globally. That is mostly coming with the reason of the waste of any kind coming from the anthropogenic activity, and human beings are sadly the main contributor to that. And such kind of the research concerning the green chemistry, or you know, also connected with the halal and alternative, more better choices in terms of the halal food available. This kind of research is really needed, and we are more optimistic and would be more glad to see more outcomes of her research in near future. So I would like to invite and make an announcement about our next speaker without taking much of your time. Our next speaker is Professor Dr. Muhammad Umair Arshad. Professor Umair Arshad is a professor and chairperson of Department of Food Science at Government College University, Faisalabad, Pakistan. And his specialty is mostly concerning the regulations related to health claims and food labeling, as well as food intake, appetite, and glycemic responses of foods, with special focus on dairy product and components. He also is focusing on the food fortification strategies and related consultancy at national and international level. So today he has joined us to speak in the topic of the role of the different form of dairy products, in fact, on short-term food intake, satiety, and postprandial glycemia in young, healthy adults. So another different topic of our today's session. Please give a big round of applause for Dr. Arshad.
Thank you so much. Thank you. Bismillahirrahmanirrahim. Rabbi shrah li sadri, yassir li amri, iqdatam min lisani, yafqahu qawli. First of all, let me praise the previous presenter, Dr. Nazimah. That is the topic which is close to my heart and everyone's heart, because we are running towards a really circular economy when we talk about the businesses. I'm Dr. Arshad. I'm working as a professor of food science and heading the food science department in Government College University, Faisalabad, as well as I'm basically a linkages kind of guy. I'm working as a director industrial linkages in my university. So all the food industry in Pakistan, we are dealing with from the standards, from production, from the waste to the value kind of concepts. Particularly, I'm presenting this today's presentation that is related more to the nutrition side instead of the technological side. So in this, basically this is also one of my expertise area that we are working on the exposure of different food and food ingredients for the regulation of different metabolic disorders in human as well as in animal studies. This particular study was basically based on the dairy. We have done a couple of other works on the dairy components, but when we talk about the appetite and the regulation of the glycemia through hormones, then comes different food technology perspectives as well. So we were ambitious to look into the different forms of the dairy products that are in the market and how they are affecting physiologically to control and regulate the metabolic responses in the human subjects. So, okay, so the obesity and type 2 diabetes unfortunately increasing at alarming rate throughout the globe, and particularly in the countries like Pakistan. We are getting on the upper side of malnutrition, that we are getting more heavyweight and obese people instead of the lower side of malnutrition. These metabolic morbidities could be controlled and through the regulation of body weight, and obviously then here comes the diet and the different other factors that can control the appetite and glucose in the body. And dairy consumption is particularly related. In the previous studies we have seen that the consumption of milk and milk products are very much related, although on the basis of the protein mainly, which is contributory, the whey protein especially, which are contributory towards the improvement in the satiety and the glycemic responses. And yes, regular consumption of dairy is already shown that it is associated with the low incidence of these morbidities, and then it is maybe due to the increased satiety responses with the more fullness and reduced appetite, and then decreased postprandial glycemia in different subjects. So that is this circle. Okay. Okay, so although we, as I mentioned, that we have already different studies related to the impact of dairy products on the glycemic regulation, but the consistency and the magnitude effects observed have varied substantially among different studies presented by different researchers. One factor could be that structural differences between the different dairy products results in behaving differently, and that depends again on the food matrix, what kind of matrix and how the absorption of these bioactive components are there in the gut. And then the no comparative studies have yet been at that time was done in the human subjects for different dairy products in this particular action. Moreover, the studies are lacking on the comparison of release of bioactive components when it comes with the full fat or fat-free or partially defatted dairy products. So that's why we have emphasized in this study that the semi-solid and solid forms of dairy products, which are obviously the cheese and the yogurt, set yogurt, and are more efficacious in case of lowering the appetite as well as the glycemia in the young healthy adults. And secondly, we also emphasize that the full fat milk that can lower the short-term food intake, satiety, and postprandial glycemia more than fat-free milk. Okay, so the objectives of the studies obviously were number one, to evaluate the effect of the farm of dairy product as well as the fat content on the blood glucose, appetite, and we were using the pizza as a for the ad lib intake, and then going to analyze different kind of parameters physiological afterwards. Secondary, as this search was in collaboration with the University of Toronto as well, so we were also very much interested to follow the Health Canada's guidelines, that how they are, the guideline particularly related to the postprandial glycemia and satiety, and how that could be to file in the future as a health claim. This was my study plan. In this, we used the randomized controlled unblinded trial, and 5 study sessions were conducted. 1 week washout period was given. Like this was within subject randomized trial in which each subject had the same treatment, and about in this study, particular study, we have subsets of 12 subjects, and which are between 20 to 30 years, and both male and female were recruited for this purpose, and they were healthy, non-diabetic, and the treatments were the water, there was a control, then skim milk was the fat-free milk we used from the Nielsen company that was provided by Canada, and then the milk for 3.25%, and the Greek yogurt from Danone company, and the cheddar cheese we used from Armstrong. So these are different treatments we used in this study. this is the treatments. When we compared their composition, so you can see that it's almost at par with each other, except there some of the differences between the protein content in case of yogurt are higher as compared to all other treatments. But overall, the caloric point of view, will see 260, 240, and how except the milk has, the full fat milk has higher calories. This was the study design. In this, the subjects were coming with fasting of 12 hours fasting, then 12 hours night fasting, and then they come in the morning. At 0 time, we take the blood glucose as well as insulin samples, and then they were given each of the treatment at every session, and then after 15 minutes, 30, 45, and so on, they were given the blood samples were taken for both insulin, glucose, and the I'm not going to present the other physiological hormones, but physiological hormones as well. Insulin and the hormones on the 30 minutes interval, and the glucose on each 15 minutes interval. And then as well, the visual analog scales were used for subjective appetite ratings at each 15 minutes. And after 2 hours, when the glucose peak comes down, then they were given the ad lib pizza intake. And then afterwards, 30 minutes, we had a final post meal reading as a post set. This is the study protocol and the results. We have seen that the pre-meal time, that is 0 to 120 minutes, the blood glucose that is area under curve from baseline that was used as a indicator in this particular chart, was lower after cheese and water compared with all other treatments for the glucose. And you can see that pre-meal, post-meal, and if you can see the cumulative, you can see the significant difference between the yogurt and full fat milk and skim milk compared to the cheese. Cheese also resulted in lowering the post-treatment blood glucose incremental area under the curve. And when we talk about the incremental area under the curve, then that actually gives the actual picture of 120 minutes to us. So again, we can see that 61% reduction in the incremental area under the curve from the control. So blood glucose level, when we see this linear graph, we can see that again the glucose level was lowest after cheese at 30 minutes, which is the peak time after the normally after taking any sugary food or glucose, and in case of but it comes down and it was non-significant till it reaches the 120 minutes time, and after the post-meal time, again we can observe that there was no difference between the milk and skim milk, but the cheese is again showing the better results there. For the subjective appetite, the results were kind of different, and we've seen the Greek yogurt and cheese both were lower after the liquid compared to the liquid dairy products, both of the skim and the full fat milk. And we can see the cumulative values here that you can clearly see the cheese is reducing as well as the Greek yogurt, particularly the Greek yogurt. And similarly, this is average appetite one-way ANOVA graph, and we can see that on 30 minutes peak time, again we can see the Greek yogurt is performing much better as compared to other treatments. When we talk about the ad libitum food intake at 120 minutes, we have seen the caloric intake in calories was lower than the control from after semi-solid, and both cheese and Greek yogurt have lowered the overall caloric intake at the ad libitum time. And this is a caloric compensation when you talk about then Greek yogurt again have shown as compared to other full fat milk. So these both have the difference, but it's not different from the cheese. Okay, so overall summary was for this study that cheese suppressed the pre-meal blood glucose level more than the liquid and semi-solid dairy products. And cheese also reduced the blood glucose incremental area under the curve by 61% more than the full fat milk when we compare it. And this is very important parameter to claim in any kind of jurisdiction, either we talk about EFSA or Health Canada or whatever. So Greek yogurt and cheese suppress the pre-meal appetite. Both of them are the semi-solid and solid foods, more than the liquid dairy products. So both cheese and Greek yogurt reduced caloric intake at the meal more than the liquid dairy products. So my conclusion is again related to my hypothesis that semi-solid and solid dairy products as well as the high-fat dairy products have more effect on regulation of short-term appetite and food intake and glycemia when we talk about the healthy adults. And I did not show the results of physiological hormones, but we have seen that the GLP-1 as well as the GLP-1 was particularly very important when we talk about the biopeptides release from the cheese as compared to the other liquid dairy products. So it was higher, I have not shown in here, but GLP-1 was higher post-treatment intake in case of cheese as compared to other products. Thank you so much.
Thank you very much, Dr. Umair Arshad, for your interesting presentation and just finishing in time very quickly, right? So it was interesting to look at his research findings regarding the intake of the dairy-based products. Though there is more to discuss, but owing to time limitation, we have to move to our next speaker of our last session. And the last speaker for today's conference day. She is Professor Dr. Suraini Abd Aziz, Professor at Faculty of Biotechnology and Biomolecular Sciences, Universiti Putra, Malaysia. Her research specialty is concerning the biochemical engineering, specializing in enzyme technology and industrial biotechnology. And today she will be discussing with us about her research outcome relevant to the topic of the bromelain enzyme from pineapple leaves that could be potential source of halal ingredients for therapeutic usage. So ladies and gentlemen, please welcome Dr. Suraini. You can start your presentation.
Thank you, Dr. Thank you for your introduction. Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. Last session and last speaker. Please bear with me. So I'm Suraini Abd Aziz from Universiti Putra, Malaysia. Today I will bring your attention to this is actually the abundant enzyme. You can see a lot of pineapple all over the world, but for us, we didn't use the pineapple. We are using the waste. Like Prof. Nazimah, we utilize the waste. So in our group, we did a lot of waste utilizations for value-added products. But today's presentation, I will talk more about the bromelain enzyme. And this bromelain enzyme, we got it from pineapple leaves, and it's a source of halal ingredient for therapeutic usage. So this is my reference. You can just search the Scopus. My name is Suraini Abd Aziz. You can find a lot of our publication and my book. So the talk outline today, I give you a little bit of introduction and what is halal criteria ingredients for Malaysia, and agro waste or pineapple waste abundance in Malaysia and all over the world. And our approach is on the biorefinery. We are working on the biorefinery approach for circular bioeconomy, and today I will talk about the pineapple biorefinery. And next is our product, pure bromelain from pineapple plant. This is not stem, sorry, it's leaves. We have utilized all type of waste, and this time I will talk about the leaf. And we utilize the pure bromelain from pineapple leaf for antioxidants and anti-inflammatory. And end of the with conclusion, acknowledgement, and some advertisement of our book that have been published. So halal means that the food is clean and does not contain any harmful or forbidden ingredients such as pork, alcohol, and blood. I think everybody is aware of this. So according to Islamic rights, halal food must be prepared in a clean environment, and animals must be slaughtered humanly. But in my case, in our case, we are not using animal, we are using plant. And halal refers to what is permissible and lawful in traditional Islamic way, and to this extent to food and ingredient as well. So the ingredient is very important in order for us to derive any type of foods. And halal ingredients are those that adhere to Islamic dietary laws, and their use is allowed according to Islamic principles. So this is just a revision. I think everybody aware on that. And to sure the halal ingredients, it should meet the criteria. First, the source. The source is very important. The source must be from halal. For example, meat must come from the animal that was slaughtered in according to Islamic guidance. The processing is very important. So in this case, the manufacturing processing is the most part that didn't include any contamination with halal or forbidden substances, and certification. So for Malaysia, we have certification for halal ingredient, and the certification have to ensure that the products and its ingredients comply with halal standard. And I just browsed through on the halal certification procedure in Malaysia, and we are working with bromelain as the ingredients. So our bromelain will fall into the pharmaceutical product scheme criteria. So in order for us to proceed with the halal certification, we should register the bromelain under the Drug Control Authority, and the pharmaceutical product that eligible for halal certification will fall under the following categories. First, it's not supposed to be the scheduled poison products, the scheduled poison products over the counter, and the health supplement products and natural products. So our targets for bromelain from pineapple leaves is to go for the health supplement products or natural products. So this is the halal certification that we in the process of getting it from Malaysia halal standard. And next, sorry, this is in Malay. This is the flow, how we can get the halal certification from Malaysia. So actually it's a long flow, but if your product really fulfill the criteria, it takes only maximum up to 3 months. And why we go for agro-waste? Same as what Prof. Nazimah said, the agro-waste is very, very abundant. And even in Malaysia, agricultural waste, if you have a look at the picture here, are abundant and diverse byproducts generated from various agricultural activities. And these residues are often considered waste, but they can be valuable resource for sustainable biorefineries and other applications. And this abundance of agro-waste, if you have a look here, you can get it either from the forestry residue, you can get it from the crop residue, from the manure, from the sugarcane bagasse, oilseed, fruits, and straw and husk. A lot of forest residue, agriculture residue can be used. For Malaysia, we have the National Biomass Strategy 2020, where we utilize all the waste to produce the product and to make it zero waste products. And what are the value of product that you can target for the agro-waste? In this case, it's a plant-derived waste. So you can go to the biochemicals, you can get proteins, pectin, you can go to biofuels, biomaterials, power and heat. So all of this type of product, we already established in our laboratory and in our research group. And what our target is, we want to go for the sustainable biorefinery. So from the waste, we're going to utilize it through biorefinery approach and through biotechnology to sustain through the circular bioeconomy and sustainable development. So they have the process inside here that is very, very important in order for us to achieve. And in this case, sustainable biorefinery have a critical role to play in our common future. So the need to provide more goods using renewable resources, combined with advances in science and technology. So in our work, we are biotechnology. I'm from the Department of Biotechnology. We combine bio and technology together to have a biorefinery system developments. And usually, when you go to the biorefinery, you can target up to zero waste. And sustainable biorefineries offer a holistic and eco-friendly approach to resource utilization. So agro-waste as a resource in this case, and providing a pathway towards a more sustainable and resilient future. Okay, this is the summary, what you can obtain, what you can get from the sustainable biorefinery that we already done in our works. So you can reduce the greenhouse gas emission. You can get the renewable feedstock. This is the main target for my talk today. Bioeconomy development, energy efficiency, waste utilization, and at the same time, the waste utilization, if you do it in the village for the farmers, you can create a job for them. Let me proceed with the talks. Okay, I will talk about the pineapple and its waste utilization. This is our book published last year, 2020. So we talk about the usage of pineapple, starting from what you can get until the products. So this is the book was published under our university press, UPM Press. So I'm one of the co-editor, one of the chief editor, 2 from Malaysia and 1 from Thailand, Dr. Suchada from Chulalongkorn University. And this is what I informed just now. We are working on pineapple biorefinery, zero waste. So what we have here, from the pineapple plantation, the fruits, we didn't use the fruits. We sell the fruits, but the peels we use, the leaves and the pineapple plant stem. This is the stem for the tree that we use. And it's covered almost 50% of the total pineapple plant. And what we did, first we go for the extraction. We extract the bromelain from leaves and from the stem, and we extract the essential oil. So the remaining after the extraction, we go for the production of ruminant feed. So we already use some. But the remaining from the pineapple plant stem, we produce L-lysine or L-methionine. This is amino acid that you can use to enhance the ruminant feed. And at the same time, the pineapple plant stem, actually it have more than 70% starch, soluble starch. So this soluble starch you can use as a precursor for production of caramel. And rather than using soya sauce from soya bean, you can produce soya sauce from caramel of the pineapple plant stem starch. And it is our other project is to produce nata di pina from pineapple peels. Besides, everybody very common using nata di coco. Our works, our study, we use nata di pina. And today, I will explain more on the bromelain that we have. And we are aware that bromelain is enzyme derived from pineapples. The commercial enzyme that we have in market were extracted from the pineapple fruits and pineapple plant stem. And it is known for its anti-inflammatory properties, and it contains a mixture of proteolytic enzyme. And it suggests that it may help reduce the inflammation and alleviate symptoms associated with inflammatory condition. So the source of bromelain in pineapple, you can get it from the crown, you can get it from the fruits, and you can get it from the leaves, and also from the stem. The one that I'm talking today is from the leaves. And this is the anti-inflammatory effect of our bromelain that we are studying now, is to reduce swelling, pain relief, improve joint function, and for sinuses relief. So for the time being, we are number 3, to improve the joint function. So we try to produce it in tablets. So you just take a tablet for the knee pain. And this is the other plant that you can produce anti-inflammatory. And it was nothing, while some studies support the anti-inflammatory effect of bromelain, but we need more research. So after the usage, after you did the production, you need to do the clinical trial. And for us, we already got the product. We are in the process to do the preclinical trial and to let the company join in our works. As a researcher, we can produce the products, but to pre-commercialize or to commercialize the product, we need a lot of money. So at this time, we need to bring the company to join us to help us in commercialize the product. And this is our product. It's pure bromelain from pineapple leaves. This is the company that work with us. So Putra Biowell Simab. So our trademark for our bromelain is Epibrom trademark. And this is a pure bromelain from pineapple leaves. And its activity is about 1,000 CDU per gram. And we already have patent our bromelain extraction, okay, in November last year. And I go through very fast about the strategy that we use. We are using a very simple procedure. I think everybody can do it, but the optimization is secret. That is because we have the patent on that. So it's very simple. This is in the lab. Sorry. So you do the extraction process. This is a very simple cold extraction process. Then you could get the crude bromelain extract. This crude bromelain extract actually already used in the restaurant in Malaysia. You can just use to tenderize the meat. And we proceed with the purification strategies to get the purified bromelain, and we are using only 2 methods here. Aminosulfate precipitation and dialysis to remove all the salts. And the system that we are using is the ATPS. This is our method that we already patent, the ATPS condition and the spray drying technique. And this is our bromelain activity. If you have a look, the activity increased a lot after we did the partial purification, with the specific activity increased about more than 50%. And with the ATPS method, okay, so you can get the system with the ATPS, so you get 2 phase and then you get your bromelain there. And the activity increase after you got 55% reducing of salts, and then it increased 34.4% of the increment. And after we got the bromelain, we have problems to make it stable. So what we proceed to dextrin as a carrier. So we are using the spray drying technique. I think everybody aware of these methods. And this is our product. So with the addition of maltodextrins, so we using using spray dryer, we got a bromelain powder. And then this powder, the color is like the pineapple fruits. And the smell is very nice. Actually, I'm thinking to bring it today, but we cannot do it last week because it's a rainy season and our pineapple is not so nice to harvest. And actually it takes about 2 weeks to start from the extraction until you got the spray dried pineapple, spray dried bromelain. And this is the characterization, or we call it product sheets of our Epibrom TM. So the size and particles is fine powder and is dissolved easily. And if you put in the very cold water, it will dissolve. You just can drink it. And that and our talks. And in this project, we produced 2 papers. So paper using the plant stem. She's my PhD student, already submitted her thesis. So we have 1 paper on the amino acid production. This one for us to use for the animal feed. Another one on the functional properties of the stem. And before I end, I would like to acknowledge my research group. We call it Bioproduct Research Group. So I'm the main, and I have 6 very young researchers, very proactive researchers. And my collaborators. I have collaborators all over the world. And Chulalongkorn University is one of my collaborators at Faculty of Science. And this is the books that I informed. So we have published books about the utilizations of waste. So the first one is the biorefinery of oil-producing plants for value-added products. We published in 2022, 2 volumes with 32 chapters. So we have writers from Indonesia, Korea, all over the world. So this is published by Wiley BCH. Next is our book on pineapple and waste utilizations. So also published in 2022 by UPM Press. And this is hot from the oven, just published October 25th this year. It's on the chemical substitute from agriculture and industrial byproducts, also by Wiley. So it has 18 chapters because we specified the type of chemical substitute from agriculture waste, except except palm oil waste, the other type of waste. And this is ongoing, will be published on January 2024. This is a handbook of biorefinery and research technology. We have 8 sections. I'm the section editor. So it will be published live spring year reference online. So with that, thank you very much.
Thank you very much, Professor Dr. Suraini. She talked about interesting research outputs of her research group, starting with the basic science, connecting with the applied science, and it's really commendable that her research contributions, not only in the area of the research, but also her contribution in literature is also like quite appreciable. So a big round of applause for her research outputs in the field. So all of the three speakers in our today's session, they shared very, very interesting outcomes of their research work concerning the green chemistry and personal health goals, as well as the sustainable economical goals, in parallel to the halal aspects of the food products, as well as the other halal origin of bioplastic as well especially from the Dr. Nazimah. So we just have a short time, maybe hardly 5 minutes, to have a quick discussion and comments or question from audience. So please, if you have any question or comments for our today's speakers, you're more welcome. Anybody? Yeah, please.
They have been commercialized. I mean, we can buy the products in the market or not?
Yeah,
Those
Dr.
two
Nazimah.
products, yes, please.
Or the products? No. Yeah, we just do the research and publish at the moment. Yeah, but yeah, we're happy to commercialize anything.
Because it looks very, very healthy.
Oh yeah, actually that avocado seed snack is quite nice.
Thank you.
Okay.
Further questions? We have, I think, from Dr. Umair.
Okay, so I really appreciate whatever you are doing. It should be gone for the commercialization, obviously. Did you go for the nutritional studies as well from these products, as well as, I think you mentioned just some of the anti-nutritional toxicants?
Yeah. So what we're doing is, we're going to characterize it, because at the moment we've just done consumer acceptance, and we will have to look at its antioxidant potential, the protein content, but I don't think there's much. It's going to be mainly carbohydrate, just like any extruded snack. Yeah,
but I'm asking about the anti-nutritional factors, if you...
we can look at that, So that's quite a lot in seeds, but usually with roasting, it will be reduced somewhat considerably.
Okay.
Okay. That's why.
Okay, we have one more question, please, on the right-hand side. Please pass on the mic.
I just have a very short question, because it's interesting even from Professor Nazimah and also Pak Suraini. It's about pineapple and also, of course, avocado. I just imagine Indonesia has a lot of abundant avocado. And then it's only just, how about the cost structuring? So we competitive, we can produce the avocado. And of course, there's a variety of avocado. This can be, your methodology can be used for all related to the variety of the avocado, because you have the small ones, big one, and also there's another size. Thank you.
Oh, thank you so much. Yeah.
Yeah, both avocado and pineapple, you know, one of the largest, largely consumed fruits, especially in the Southeast Asian countries. And these were very natural and very interesting aspects of using the utilization of the waste products. That is quite a bulk amount. Like we can see the seed is quite in bulk for the avocado, and the pineapple, including its crown, is just like a big waste of the fruit that is could be possibly utilized in so many ways, connecting the biochemistry and concerning the utilization of the dairy products from Dr. Umair's research outcome can also be broadened by studying further about the plant-based cheese to further broaden the scope of the research for the vegan-based food products as well. So with that, if we don't have further questions, though I would love to discuss further about those fields, but we just have a very short time now to compile the session. I would like to conclude today's session. Thank you very much to 3 speakers in our last session for your very valuable and interesting information concerning the topic of the halal-based products, and very much relevant to the title, like the digitalization of the halal initiatives for fostering the halal trust. And we look forward further to more outcomes coming ahead in the future from your research work. Thank you again. And thank you to the audience for taking your interesting questions and comments to just put more value to the scientific aspects of halal-based industry and the products, both concerning the food and pharmaceutical industry as well. Thank you very much, all of you.